In this video, we are going to start our complete Rust playlist. We are going to cover each and every topic in this playlist, from variables to all the way to generic traits, lifetimes, collections, structs, enums, all the advanced concepts. So we'll go video by video covering each and every topic in detail. Yeah, so stick around till the end, and I assure you this is the only playlist that you'll need to master Rust. So yeah, let's begin. So firstly, let's create a project, a Rust project. So it is very simple to create a Rust project. Just open the command line and write cargo and followed by the project name. So I'm not going to do that again because I've already created a Rust project. So after you create a Rust project, the folder structure will be something like this. There will be a source folder. Inside it, there will be a main.rs file and a target folder. We'll talk about it later. And then a cargo.toml file, which is important. So if you have any programming experience in JavaScript or Node.js, so the cargo.toml file is pretty similar to the package.json file. We'll store all the dependencies, their versions, and everything, every other important information over here. So yeah, we'll talk about it in detail in some later video. Right now, just focus on this main.rs file. So in this main.rs file, we get a function main. So fn is the keyword for a function. We'll talk about functions later. But the main function is somewhat special. This is where the execution of your entire program begins. Now, if you have any experience in a language like Java, so there is a function called as public static void main. It is pretty similar to that. The execution of your code begins from the main function, and any other piece of code that you have written in any other file or directory will be compiled and run as and when their references are cited in this main function. So that is what the main function is. Now let us understand our first topic, variables. Pretty simple. Just like any other languages, variables are containers that we use to store value and then retrieve those values, use them, do math with them, and stuff like that. So this is a code. Let's try to understand this code snippet. We are declaring a variable with the first statement, let x equals to 5. Then using the println statement, we are trying to print the value of x. Then we are changing the value of x to x equals to 6 and again printing the new value of x. Now, if you are from a JavaScript background, any language that like that, then this code is perfectly fine. It will run, but it won't in Rust. So this is where the concept of mutability and immutability comes in play. Every variable or anything that you declare in Rust is immutable by default. It means that once you have declared it, it won't change. If you try to change it, it will give you an error. So that is what will happen over here. This code will not compile because x over here is not mutable and we are trying to update it to 6 later on in the code. So that is why this won't run. So let us now see what is mutability then. How to make your variables mutable so that you can change it. Before that, let us understand why is this feature in Rust? Why are everything mutable and immutable? So the reason behind that is ki, let's say if you declare any variable in your code which you don't wish to change, and accidentally in the future you change it, you end up changing it and you don't get the desired output. So to prevent errors like that, bugs like that, there is a concept of mutability and immutability in Rust. So the variables which you don't want to change, declare them as it is simply with the let keyword. And the variables which you want to change in the future in your code, you have to explicitly declare them, mention them as mutable variables using the mute keyword, mut. So this is one benefit which will save you from a lot of bugs and errors that you might encounter in production. So yeah, let us just quickly code this into VS Code. We'll declare a variable let x equals 5. Then we'll print the value of x using the println statement. We'll also discuss the println statement in detail in upcoming videos. Value of x is, now inside the println statement we use curly braces as format specifiers, and inside it we specify the value that we want to print, in this case x. Each statement ends with a semicolon. And now let's try to update the value, let x equals 6, and then print the new value. Now, as I said, this code won't run. See, it's already giving me an error, a red squiggly line under the x equals 6, enforcing the concept that x wasn't declared as a mutable variable, so you can't change it. So let's try to save it and run it, and let's see what error the compiler gives us. So to run any program, we have to check it first. Now it's not mandatory, but it's a good practice that to check the code you have written before actually running it. So to do that, you just type cargo check this command in the terminal and run it. As you can see, we get an error. Let's try to read through the error. It says cannot assign twice to a immutable variable. Pretty straightforward now, as we understood the concept of mutability and immutability. So how do we make a variable mutable? How do we solve this problem? Very simple. You just add the mute keyword while declaring the variable. So now we declared the variable something like let mute x equals to 5. Just forget this I32 for a moment because this is a data type of x and we'll get to it later. So now when I try to save the code, as you can see, the error went away, the red squiggly line went away. Now let's again try to check our code before actually running it using cargo check. As you can see, we didn't get any error this time, so now we can go ahead and run our program using the cargo run keyword. So yeah, this gives us our desired output. Now we declared x as 5, then we print x, the value of x, which will be 5. Then we update x to 6 and then again print the updated value, which is 6, as reflected here in the second line. So this works perfectly. So now that we have understood variables and how they can be mutable and immutable, now let us understand what are constants and how they are different from variables. So constants are always mutable. You don't have a choice to make them. Constants are always immutable. You don't have a choice to make them mutable. So even if I want to make a constant mutable, I cannot. And just like variables were declared using the let keyword, constants are declared using the const keyword. And it is a convention to name the constant in all caps with different words separated by an underscore. And again, this U32 over here is just the data type. We'll get into it later. So yeah, that is the difference in constants and variables. Variables, you get option. It can either be mutable or immutable. Constants are always immutable. You cannot change them once they are declared. Also, constants can be declared in various scopes or they can be declared in the global scope. So we'll get to scopes later. At that point, we'll understand this point in much detail. But yeah, that is also one feature of constants. So let's say you write a code to calculate some physics problem, the solution to some physics problem, and you want the speed of light. Now the speed of light will always remain the same, so you declare it as constant. So even by mistake, you don't update its value in your code while running it. So yeah, that was all about constants. Pretty simple. I hope you guys understood till here. Now there comes a concept of shadowing. This might be a bit confusing for beginners if you are learning Rust or a low level language for the very first time. This might be a bit confusing. Otherwise, this is pretty straightforward. Let's read through it. So declare a new variable with the same name as the previous variable. And then the second variable is what the compiler will see when you again use the variable. So let us understand it through this code snippet over here. As you can see in the main function, we are declaring a variable x equals to 5. Then in the next line, we are writing let x equals to x plus 1 and changing the value of x to 5. Not actually changing, we are just shadowing the value. We are just hiding the previous value of x, which was 5, and making it look like x is 6. Now you might be having one question that you said ki we can only update mutable values and x was not declared as mutable over here. So that is what the difference in changing a value and mutating a value and shadowing a value is. Over here, the value of x is not actually changed. It is only shadowed by a temporary value, which will be x plus 1, 6 in this case. So now when the compiler sees x, it will see it as 6, not 5. So the value 5 is hidden temporarily until and unless this declaration let x equals to x plus 1 will either go out of scope or become invalid. Now in the next line, we are declaring a block of code with the curly braces. Inside that, we are again shadowing the value of x to x times 2. Now, just before this block of code, the value of x was 6 because the compiler thought it was 6, but actually the value of x is 5. So we had shadowed it once, made it look like 6, and inside this block of code mentioned by this curly braces, we are again shadowing it and making it look like it's x times 2. Now that is 12, which is 6 times 2. Then we are printing the value of x inside the scope, and when this block of code ends, after the end of these curly braces, the inner value, the inner shadowed value will become invalid. So the inner shadowed value of x was 12, that will become invalid, and then x will again go to its previous shadowed value, which was 6, due to this statement, let x equals to x plus 1. Now then we print the value of x again. This time it will print the shadowed value, previously shadowed value, which was x equals to 1. And at the end of this print statement and the block, the shadowed value will no longer be valid, and even the variable x won't be valid, but that we'll see in the concept of ownership. For now, just understand, as the block of code ends, as the main function ends, the shadowed value will no longer be valid. Now let us try to code this and see it in action. So let's comment out our initial code. Now to comment, we just add two forward slashes before the beginning of each line, or you can just select the number of lines you want to comment and then just control and forward slash. That would comment all the lines. So let us now see the second code, which is this in action. We declare a variable let x equals 5. Let me shadow it using the let keyword again. Let x equals x plus 1. We start a block of code using the curly braces. This is also called as a scope. So now let's again shadow the value of x. Let x equals x times 2. Then let's print this shadowed value of x. Value of x in inner scope. Curly braces again as the format specifier and the value x inside it because we want to print x. Then let's come out of this code block and again try to print the value of x. So value of x here is curly braces and x inside it. Let's try to run this code. Let's save it. And as I said, it is a good practice to do cargo check before you actually run it. So let's do cargo check, run it. As you can see, we got no errors or warnings. Now let's run this code. I'll just clear the terminal before that. Yeah, now let's run it. As you can see, we get output. Now let's try to understand this. The value of x was first 5. Then we shadowed it to 6. So now the compiler thinks that the value of x is 6. Then we go inside the block of code and then we again shadow the value of x to x times 2. Now the compiler thinks that the value of x is 6 times 2, which is 12. Then we print the value and we get our first line of output. The value of x in inner scope within these inner brackets is 12. Then we come out of this bracket and the previously shadowed value of x, which was 12, that becomes invalid. Now finally we print the value of x, which is 6, because that was the shadowed value in the outer scope outside these two curly braces. So that is it. I hope you understood the concept of shadowing. In shadowing, we don't actually change the value of x. We just make the compiler think that the value of a certain variable is something else for a short period of time. That can be a scope or function, something like that. So we'll see like numerous examples as we move forward through this playlist on how mutability, immutability works and the concept of shadowing. We'll use it multiple times. So even if you don't understand it at this point, it's okay, because we'll go through it multiple times in the future. So yeah, let's see one more example. Let's clear the terminal first. Let's go to the blackboard and let's see one more example. So we are declaring spaces, variable spaces, which is nothing but an empty string with some number of blank spaces, and we are declaring it as mutable. Now we change spaces to spaces.length, which just gives us the length of this empty string. which is the number of spaces because the string is empty. Now let's try to run this code, and this code won't compile. Let's see what the error is. Let me comment out the previous code. Let's try to run that code. Let variable spaces equals an empty string with four blank spaces. Now this and str that you can see over here, forget about it for a moment. This is the data type. We'll see that in a later video. Then we do in the next line spaces spaces len. Len is just a function which will calculate the length of that string. Even if it is blank, it will calculate the number of spaces in it. Now let's try to run this code. As you can see, as I saved the file, it gave a red squiggly line under spaces.length. But let's try to read what the error the compiler gives us. We'll try to check the code first using the cargo check statement. As you can see, it gave us an error. Expected and str found u size. So you should have bit of a knowledge about data types for this. But what is happening over here is we are declaring a mutable variable spaces which is equal to an empty string. Then we are trying to change the value of spaces to spaces.length. Now what happens over here is spaces is a mutable variable but it stores a string, and even if it is mutable, when you change the value of spaces you should change it to the same data type which is a string type. But spaces.length will return the length of the string which is a number. So this mismatch of types is not allowed in mutable variables also. So that is why the error is over here. Now let us see how we can fix this. So we fix this using shadowing, because shadowing lets us even change the data type of the variable that we are shadowing. So let's understand this code. We are declaring spaces, which is just an empty string with some amount of blank spaces using the let keyword. Then we again shadow it using the let keyword. Let spaces equals to spaces.length. Now the compiler will think that spaces contains the length of the spaces, which is nothing but the number of blank spaces. Because we haven't declared spaces as mutable, instead we had shadowed it. So in shadowing, the mismatch of types is allowed, but in the concept of mutability, even the mismatch of types is not allowed. The type has to remain same even if you mutate the value of the variable. Now let's try to run the correct code. I have to shadow it using the let keyword. So let spaces equals to spaces dot the length function, which just returns the length of the string. Now when I do control S to save the file, the error goes away. Now let's try to let me just clear the terminal. Now let's try to check the code before we actually run it using the cargo check command. As you can see, we get a bunch of warnings, but these are not errors. The warnings are just because we don't use the spaces keyword or the variable spaces that we declared. So to get rid of that, we'll just add an underscore over here and an underscore over here. And yeah, the warning goes away. Let me just clear the terminal again and run cargo check. As you see, the warning went away in the second line, and now there are no errors. We can actually run the program. Let's do it using cargo run. As you can see, the program executed, but we didn't get any output because we didn't print anything. Let's try to print the number of spaces using the println statement. So now let's save it, and let's now try to run it again. Let's clear the terminal, cargo run. As you can see, we get an output stating the number of spaces are 3. So this is the key difference between shadowing and mutability. In mutability, we can change a variable, but the data type should remain same. And in shadowing, we can also change the data type of the variable. So I hope you understand this code, this pieces of code and these concepts that we discussed today. And the next video will follow up with some even more advanced concepts. Till then, keep watching, and I hope you guys subscribe and like my videos. Thank you.